All right, so we're going to start by looking at the Magic Hexagon. Now, I haven't taught this in a couple of years because it's really more for if you need to actually know your identities, like you have to have them memorized type of thing. But then somebody had it drawn on their paper yesterday because somebody showed it to them. So I thought, I'm going to go ahead and show y'all. It's kind of debating between whether or not it was going to make things more confusing or not. Because it is possible that in college, when you need to apply this stuff, maybe the expectation is that you know them and that you're not going to have a chart. I mean, that's definitely a possibility, right? Y'all take your hoods off, please. And so I just want to at least show it to you, but know that, you know, and I think some of you would find it totally interesting. Some of you will never look at it again. It's just whatever. Just to show you how it works. So if I have a hexagon, if I draw a hexagon, and we have to have it labeled this way or it's not going to work. But really, if you can get tangent, sine, and cosine in the right places, then the function across from them is their reciprocal. So it's easy to get the other ones in there. So there's a lot of really cool things that happen with this. So to get your quotient identities, you can follow around the clock. And, oh, this is going on 112. Right? 112? No. Okay. You can follow around the clock in either direction to get them all. So tangent is sine over cosine. That also means that cosine is sine over tangent. All right? And it is. So watch this. Cosine theta equals, so this says cosine is sine over tangent, right? So this is sine theta over tangent theta, but can't I write that as sine over cosine? So then when I multiply by the reciprocal, this will give me cosine theta equals sine theta times cosine theta over sine theta. And then those cancel out, so cosine equals cosine, right? So you can get there, like that's a true statement. So you're not expected to know all of these. But if you're going to use this like a ton, which we're using it some, not enough for you to have to worry about all of these. But again, this is just kind of a, this is how it works type of thing. Substituting those things in might make it quicker. I do not want you using these for your assignments though, because you're not going to get this on your test. You're going to get this pink card. And then even though it might make it a step quicker on your homework, then you're not going to know how to work through it when you need to. You with me on that? So this is just kind of this is what happens. So it works on all of them. Secant is cosecant over cotangent. Secant is tangent over sine. Like, they're all right, and we could prove them all like that. We're not going to, but we could. All right. So that's kind of cool with the quotient identities. Then we have the product identities. Okay, so it says any two functions is equal to them multiplied together. So you get tangent times cosine gives you sine. Sine times secant will give you tangent, because they come in like this. Tangent times cosecant gives you secant. Okay, and that's like just if we set up the reciprocals and things canceled out, that's what's going to happen. Then when they're across from each other, because they are across from their reciprocals, it equals 1. So tangent times cotangent's 1. Sine times cosecant's 1. Cosine times secant's 1. Okay, so just another kind of cool thing about that hexagon. So if you had to know all these, if you could just draw your hexagon real quick, you got all this stuff on there. Oh, we're getting there. So reciprocal, well, we've already said they're across from the reciprocals, so that's kind of how you set it up anyway. So then, to answer Michael's question, the Pythagorean identities, then these little triangles. Sine squared plus cosine squared is 1. Then 1 plus cotangent squared is cosecant squared. Tangent squared plus 1 equals secant squared. See how that works? You just draw the little arrows in your triangles, and you're good, okay? So it's this one squared plus this one squared equals this one squared. And the arrows go in the same direction for all of them, okay? All right, and then you can also travel reverse. So if I could say 1 minus cosine squared equals sine squared. So cosecant squared minus cotangent squared is 1. That's how you get the other ones. Then we have the cofunctions, right? So sine is equal to cosine of pi halves minus theta. Tangent is equal to cotangent of pi halves minus theta. Secant is cosecant of pi halves minus theta. Okay, just like that, that's some of those things that are on there too. So it kind of is all encompassing. So again, this is just kind of an FYI. I know there'll be some people that kind of found it fascinating, and some people, I know some of you don't even care, but it may be helpful to you in the future, like I said, if you are ever expected to actually know them, that you still don't have to memorize everything. You kind of understand it like you do with some other things, okay? So there you go. That's just going in there as an FYI. So now let's look at what we're really doing today. This is going on page 113 when we are done. All right, so today We are proving trig identities. So tell me how an identity is different than an expression. How's an identity different than an expression? It has an equal sign, because identities are equations, right? So proving the identities means we are going to have equations all along the way. But, stop talking. We're still not solving. We are proving, which is also the same as verifying, not solving for anything, okay? But we have equations the whole time. So it says proving or verifying an identity. Proving or verifying an identity means to show that both sides of the equation are the same. So to prove an identity, you simplify one side of the equation until it equals the other side. So we're not working with both sides. We pick a side, we work with just that one. This is not one of those, whatever you do to one side, you do to the other. No, because we're not solving, okay? So the hint here, this is an important hint, work with the side that looks more complicated. Because it's going to be way easier to take something that looks more complicated and simplify it down than to take something like this that's all simplified and figure out what to put in there legally to make it look like that, right? It's easier to go the other way. So I would say on number 1, the left-hand side definitely looks more complicated. We agree with that? Okay, so I'm going to circle the right-hand side because that's our goal. We need the left-hand side to equal cosecant theta. Which, honestly, we already know it does. Like I gave you the answer. The answer is cosecant theta. You got to show me how to get there. So when I look at this and think about the same options I had yesterday, I could substitute some Pythagorean stuff, but I don't know that that would really help me at this point right now. I think I would rather try and figure out and use my reciprocals first. So what's the reciprocal of cosecant? Sine. So this is 1 over sine, yes? And 1 over sine times cosine squared will be cosine squared over sine. Plus sine theta equals cosecant theta. You keep writing that other side. Okay? And it doesn't change. Okay, so now I do know that cosine over sine is cotangent. So I could have cotangent times cosine, but I don't know if that would help me. Instead, I think I want to combine these two, so I need a common denominator. My common denominator will be sine. So this first term will be cosine squared. This second one had to be multiplied by sine, so it's sine squared theta. Oops. And that equals cosecant theta. Everybody good so far? Oh, and I don't think I said this at the beginning, but it's so good for most of you. You need this handy, because staring at me is not going to get you anywhere. I know most of you have it out, but you need that reference sheet, because that's where everything's coming from. Uh-huh. What do you mean the whole thing? I would never do that to get a common denominator. Yeah, I'm getting a common denominator. When I do that, I would never multiply both sides of the equation. Yeah, okay. All right, so now, what can I substitute? 1. Cosine squared plus sine squared is 1. So this is 1 over sine theta equals cosecant theta. And what's 1 over sine theta? Cosecant theta. So I get cosecant theta equals cosecant theta, and I am done. So this is actually a little bit better than the simplifying, because on the simplifying, you didn't know if you were right or not. You had to check with me. On here, you know what your goal is, so you know if you get there or not, right? You just got to make sure you're not making stuff up in the middle of it. Well, you can work with either side. I mean, it's possible on all of these to work with either side, but you want to work with the side that's more complicated, because if I want to make it look like this and I have this, then I'm going to have to figure out what in the world I can legally add to it, and there's none of this, whatever you do to one side, you do to the other type of thing. And so I would have to, like, multiply by a value of 1 or I'd have to get pretty creative. And on some of these, like, because, there's more on both sides of this one, it would probably be easier to start with either side on there. But again, one side's usually a little bit easier to work with than the other side. Okay. So on number 2, which side would you say looks more complicated? The left, okay? I would say the left too. So this is our goal right here, okay? You can also think about which one do I have more of a, which one am I more likely to be able to find stuff to do stuff with? That's kind of what you're looking for. All right, so I've got this sine squared y over cosine y. So again, sine over cosine is tangent, and then I would have tangent times sine, but I don't know if that helps me. What does help me knowing what my end goal is that on the left-hand side, I have one term. On the right-hand side, I have two. So somehow I'm going to have to get two terms out of this, right? So could I substitute something that would help me get along that way? And again, staring at me doesn't do you any good. You look at this. Could I substitute that could get me to... Well, I could, but that's still just one term because I'm multiplying. What can I substitute? Look at your identities. Look at the pink. What have we substituted for sine squared a lot? One minus cosine squared, yes. So I can make this 1 minus cosine squared y over cosine y equals secant y minus cosine y. So now, I technically still have one term on the left, but I have two terms in the numerator, so like I'm getting there, right? So knowing what I have and knowing what my goal is, what would be a good strategy to do next, do you think? What could we do? Yeah, I would split them, right? Because I need two terms. It's not a fraction, right? So I've got that. I can split my fraction. I can make this into 1 over cosine y minus cosine squared y over cosine y equals secant y minus cosine y. No, because you're splitting. That is me splitting the fraction. You got to split the fraction, and then you got to do it. Yeah, you can't skip steps when you're proving. There's little tiny things you can skip, but you can't skip steps like that. Yeah. Uh-huh. What do you mean cross out? Wait, what am I canceling out? We are not solving anything. Well, you said mark out the secant y, is what he said. Okay, so what is 1 over cosine y? Secant y, okay. Minus, what's cosine squared over cosine? Cosine y, okay. So now it's equal to secant y minus cosine y. And then those are equal, I am done. Okay, we good? Okay, but the answer was no to jumping from here to here, because how the heck did you get that? You got to show that you split the fraction, because remember, we're proving or we're verifying. Somebody has to be able to follow every single step that you are doing. Okay, we good? All right, let's look at number 3. Which side looks more complicated? The right side. Oops, I agree with that. So this is our goal. Okay. So let me go ahead and write down the left-hand side. Cosine squared alpha equals, so what do you think I could do on the right-hand side there? Can I get rid of the sine squared a? How do I get rid of it? Okay, what's sine squared times cosecant squared? 1. They're reciprocals of each other. Or another option, if you don't recognize that, because I don't know that everybody always recognizes that, so we'll do that and then I'll show you something else. But yeah, these cancel out and become 1, right? Minus sine squared alpha. So then cosine squared alpha equals what? Cosine squared alpha. Yep. Okay, so another option, if you don't recognize the reciprocal right away, because not everybody will, we could do cosine squared alpha equals, I could factor out my GCF. Sine squared alpha, and that would give me cosecant squared alpha minus 1. Okay, I also want you to see that if you think about it completely differently than somebody else, you can still get there. So then can I substitute something for the cosecant squared minus 1? Again, look at the pink paper. Those of you staring at the board and staring at me, you're never going to figure anything out. What can I substitute? Cotangent. So cosine squared alpha equals sine squared alpha times cotangent squared alpha. Right? So cosine squared alpha equals sine squared alpha times cosine squared alpha over sine squared alpha. And then those cancel out, so again you get cosine squared alpha equals cosine squared alpha. And before you even say, well, the first way was easier, yes, it was, if you recognize that. If not, if you jump in and you do something else first, just go with it, because you can still get there, okay? Where did I get the what? Wait, this one? This one? The first one? Because these are reciprocals. You multiply them together and they give you 1. Okay? This cosecant is a reciprocal of sine. We good? All right, let's look at number 4. Which side's more complicated? Left, absolutely. Okay, no question about that one, right? Okay, so I could distribute that tangent, but I don't know that I want to distribute it right now, because although it would cancel out with that first fraction, in the end I would still have 2 terms, and I'd still have to get common denominators, so I think I would like to get a common denominator before I made it more complicated. I just think that might be the best way to look at it. So we're going to take tangent x, we're going to multiply it by, and we'll get a common denominator. Our common denominator will be tangent x, secant x. So this first term has to get multiplied by secant, so this will be secant squared. This one has to be multiplied by tangent, so it'll be tangent squared. And then that's going to equal cosine x. So, do you see anything that you could substitute? On top it would be 1. Because tangent squared plus 1 equals secant squared, so secant squared minus tangent squared is 1. So tangent of x times 1 over tangent x secant x equals cosine x. Now what can I do? Yep, I can cancel out the tangents, so I get 1 over secant x equals cosine x. What's 1 over secant? Cosine. Cosine x equals cosine x. And there you go. From that Pythagorean identity, it says tangent squared plus 1 equals secant squared. So that means that secant squared minus tangent squared has to equal 1. You see that? Okay. Well, yeah, and when you do this, like you could, for secant squared, you could substitute in tangent squared plus 1, and then the tangent squareds are going to cancel out, then you get 1. I mean, you can do it that way if you want. But, okay, we all good? All right, let's look at number 5. Cotangent squared equals cosecant squared minus cosecant squared times sine squared. I would definitely say that the left side or the right side looks more complicated. So cotangent squared theta, what can I do on the right-hand side? 1. These are reciprocals, yes? Yes, so cosecant squared theta minus 1. Cotangent squared theta equals, what's cosecant squared minus 1? Cotangent squared, and you're done. Okay. We good? All right, look at number 6. How's number 6 different than the other ones we've done so far? There are negative u's in there, right? And I have to make it equal to secant of positive u, which means I need to handle the negative u's, and I think I want to do it first just to get rid of them. So, what is tangent of negative u? Negative tangent u. What's sine of negative u? Negative sine u. Plus, what's cosine of negative u? Cosine u. No negative there. That's equal to secant u. Okay, so now my negative u's are gone and I can just handle all that stuff. Okay, we okay with all that? All right, so this negative times negative is going to be positive, so I can just not even worry about the sign. So I think I want to take tangent and make it into sine over cosine. So if I take sine over cosine and multiply it by sine, that's going to give me sine squared over cosine plus cosine equals secant. So what do you think I need to do next? Combine, get a common denominator. Yes, so my common denominator will be cosine. So this is sine squared plus what? Cosine squared. And that equals secant u. So what's sine squared plus cosine squared? 1. So I got 1 over cosine u equals secant u. So secant u equals secant u. Okay. What questions do we have? Anything? Awesome. Okay. Number 7. All right. Which side looks more complicated? I agree. So let's start. We want to make it look like this. So we get 1 plus sine squared theta equals. Okay. So I have to decide what I want to do over here. I don't know that I want to go the quotient reciprocal route because I have those 1s in there. But let's figure out what would help us to substitute. Okay, but like which one? What am I going to substitute? Yeah, I think the bottom one being cosecant squared would be helpful. I don't know that substituting anything in the numerator, even though I could, I don't know that it would be helpful. Would you agree with that? Like we could just try one at a time, see what happens. So I'm going to leave the numerator, 1 plus cosecant squared theta over, and this would be cosecant squared theta. Okay, so now that I've gotten this far, I could split them. Yes, so I get 1 plus sine squared theta equals 1 over cosecant squared theta plus cosecant squared theta over cosecant squared theta. Rewrite my left side, 1 plus sine squared theta equals, okay, so what is 1 over cosecant squared? Sine squared. And cosecant over cosecant is 1. Do these look identical? No. So 1 plus sine squared theta equals 1 plus sine squared theta. And now I'm good. Just because you know that they're the same doesn't mean that they really are, like that they have the same value doesn't mean that they look identical, and that's what we're trying to go for there. Okay? We good? What questions do we have? Nothing? All right. Which side looks more complicated on number 8? The right. I agree with that one too. Okay, so I already have a combined fraction. I don't know that splitting it would really help me at all. I don't have anything Pythagorean in there that I can substitute. So I'm thinking my reciprocals and quotients are my only option, plus this is sine and cosine, so turning these all into some version of sine and cosine would probably be the most helpful. So we've got sine u plus cosine u equals. So the numerator is going to be 1 over cosine u plus 1 over sine u. Denominator will be sine u over cosine u plus cosine u over sine u. Right. So now, I have lots of fractions in a fraction. But I think the only thing that's going to get me anywhere is combining all that stuff. So I need to get common denominators in the numerator and denominator. So sine u plus cosine u equals. Okay, so here's my big old fraction bar there. In the numerator, my common denominator will be cosine u, sine u. This first numerator has to get multiplied by sine, and the second one has to be multiplied by cosine. Then in the denominator, my denominator will also be cosine u, sine u. The first term needs to get multiplied by sine, so it'll be sine squared. Second one needs to be multiplied by cosine, so it'll be cosine squared. Now, normally I would like to clean up my fractions before I really start worrying about substituting anything, but do you see something obvious that could be helpful to go ahead and do? The 1. The sine squared plus cosine squared, what's that? That's 1. So I'm just going to go ahead and make that 1, because that'll just simplify things a little bit. All right, so then I'm going to rewrite the left side, sine u plus cosine u, and then yes, I'm going to multiply by the reciprocal. So the numerator is sine u plus cosine u over cosine u sine u times, then I have to multiply by the reciprocal. Some of y'all are having issues with that. You think you are, but you don't actually flip it, which means it's not the reciprocal. So this is cosine u sine u over 1. Then it all works out beautifully because those cancel out, and you get sine u plus cosine u equals sine u plus cosine u. And there you go. Check. What questions do you have? Okay. Let's look, bless you. Let's look at number 9. Which side do you think looks more complicated? Probably the left, like more complicated, or I have more chance of actually substituting and doing stuff with. So we're going to go with the left, right? So we want to make it look like this side, which means I need to start by actually squaring this binomial, which is not cosine squared plus cotangent squared, right? Okay, because you have to actually FOIL it. And this is a special case, so if you know your rules, that makes this super easy. It is cosecant squared A plus 2 cotangent A cosecant A plus cotangent squared A equals 1 plus cosine A over 1 minus cosine A, okay? And there was no magic there. That's actually multiplying squaring binomials, stuff you got to know, and I'm not reteaching for the 5 millionth time. Okay, so now when I look at this left-hand side, I've got a ton of stuff I could do. I could substitute some Pythagorean stuff, but at the same time, I know what my goal is, and my goal has just cosines in it, so I think I might be better off going the reciprocal and quotient route to try and get everything in terms of sine and cosine, okay? So cosecant is 1 over sine squared. Plus, then this is going to be 2. Now, cotangent is cosine over sine, right? Cosecant is 1 over sine, so this will give me 2 cosine over what? Sine squared. Plus, cotangent squared will be cosine squared over sine squared. And that's equal to 1 plus cosine A over 1 minus cosine A. Okay, so I have 3 fractions, but the good news is I already have a common denominator, right? I mean, it just kind of happened for me. So my denominator is sine squared A. Do you see how the numerator is going to become a quadratic? Or it is a quadratic, I guess. Right? Yeah, it totally is. So we're going to write it in the order that we write quadratics, which is with the squared term first. So cosine squared A plus 2 cosine A plus 1. And that's going to equal 1 plus cosine A over 1 minus cosine A. Why is this not squared? Because cotangent is cosine over sine, and this is 1 over sine. So it's just a cosine in the numerator and sine squared in the denominator. Okay. All right, so now that I'm here, and knowing what my goal is, like thinking about what your goal is important too. So, there's some things I could do here, but I think substituting something right now could probably get me on the right track. So what could I substitute? 1 minus cosine squared. I would change the sine squared to 1 minus cosine squared. So let's rewrite the numerator. Cosine squared A plus 2 cosine A plus 1 over 1 minus cosine squared A equals 1 plus cosine A over 1 minus cosine A. Okay, so the denominator, what kind of equation is that? Which should be glaringly obvious. It is a difference of squares. You got to be able to recognize them, to multiply them, and to factor them. So let's factor the denominator. This is going to become 1 plus cosine A times 1 minus cosine A. Okay, so the numerator, what do you think? It's a quadratic, so what should I be able to do with it? Factor it. Okay, which again, yeah, it's got a trig in it, but that shouldn't be any big deal, and it's a special case. The B term is 2 times the A term, which means that when you factor this, you get cosine squared A. No, I'm sorry, you don't. You get cosine A. Sorry about that. Uh-huh. Yeah, it's basically like, see how this is A squared, this is C squared, or, you know, or X, Y, whatever, but then this right here is 2 times these two multiplied together. So what's happening here? Got to be able to factor. Factoring is going to be the downfall for a lot of you, because I haven't been lying. It's not going away. You have to be a factoring rock star. Okay. Not necessarily. It doesn't matter either way. It'll still cancel out. It'll cancel out. Okay, so can I reduce here? Yes. I can reduce one of these with this. And then again, since I know what my end result is, I'm going to write the numerator the other way. So 1 plus cosine A over 1 minus cosine A equals 1 plus cosine A over 1 minus cosine A. And we did it. I mean, if you're thinking, oh God, I have no idea how to factor and I'm never going to be able to figure any of that out, you probably want to go change your schedule, and calculus is not for you. Just saying. Okay, number 10. I'm missing a fraction bar. At least there was only one missing. I don't know. I kind of got lucky on that one. Fix that. All right. So let's look at number 10. And which side would you say looks more complicated? Absolutely. So we want it to look like this. Can I substitute this 1 minus cosine y? Can I replace that with sine y? No, because it's not squared, right? So I don't have anything Pythagorean in there. Reciprocals really aren't going to do anything. So I think I need to combine my fractions. So the common denominator is going to be 1 minus cosine y times sine y. Right? Which means this first numerator has to be multiplied by sine, so it's going to be sine squared y, plus, then this one has to be multiplied by 1 minus cosine, so it's going to be 1 minus cosine y squared, equals 2 cosecant y. So usually with the denominator, like maybe you want to distribute, but maybe not, so I would always just kind of hold off on that. But we got to do some stuff in the numerator, or we can't do anything. So this is going to be sine squared y. My denominator is still going to be 1 minus cosine y times sine y. And then I'm going to need to square this, which is, yes? Huh? Yeah. If this is not 1 minus cosine squared, right? You don't just square both of them. So this is going to be plus 1 minus 2 cosine y plus cosine squared y. And that equals 2 cosecant y. Okay, everybody good so far? Now, do you see, so I can't really clean up the numerator, like combine like terms, because there aren't any to combine, but can I substitute anything? Okay, good. No. Yeah. Yeah. Okay. What is there anything I could substitute at this point that might Be helpful. Yes. What? Good. Even though they're not next to each other, you got this sine y and this cosine y that are both positive. They're going to be added. What does that give you? 1. And then when you take that 1 and add it to this 1, it gives you what? 2. So I'm actually going to be left with 2 minus 2 cosine y in the numerator over 1 minus cosine y times sine y equals 2 cosecant y. What should I do next? Factor out the 2. So we get 2 times 1 minus cosine y over 1 minus cosine y times sine y equals 2 cosecant y. Now what can I do? I can cancel those out. So that gives me 2 over sine y equals 2 cosecant y. What's the reciprocal of sine? Cosecant. So 2 cosecant y equals 2 cosecant y. And there you go. Yay! What questions do we have? Now remember, just like I said yesterday, you can do this. Don't stare at a blank piece of paper. Like, look at the paper, look at the identities that you have, do something, substitute something, get somewhere, okay? Don't just be paralyzed.